Okay, let us derive an important equation or important relation from the chapter current electricity. Now we have two terms, very important terms, that is current density and conductivity. Current density is denoted by the letter J, conductivity is denoted by sigma, and E is nothing but electric field intensity. So let us derive this relation in a very simpler way. Here we have our key formulas for this. We need to remember this key formula to derive this expression. The key formulas are J is equals to I by A. J is nothing but current density, that is equals to current by area, or you can also say current per unit area. E is nothing but electric field intensity, that is V by L, and sigma is equals to 1 by rho, that's the resistivity. R is equals to rho L by A. So this is the formula that we have, and here R is nothing but resistance. Okay, resistance, we know this well-known formula for everyone. So these are the key formulas that we need to know to derive this expression in a very simpler way. So let us understand this derivation with a diagram. In the diagram, we can find there is a conductor. Okay, the conductor is connected to a battery here, and so we know that is a positive terminal of the battery, negative terminal of the battery, and so we can see the conductor here. So as I said, there are the free electrons. There are more number of free electrons will be moving from negative terminal of a battery towards the positive terminal of a battery. So this is the direction of flow of electrons, and the electric field will be in opposite direction. So this is the direction of electric field. And what is the geometrical shape of the conductor? That is, we have a length of the conductor is denoted by L, and area of the conductor is denoted by A. That is, area of cross section of a conductor is denoted by A. And the current which is flowing from a positive terminal of a battery towards a negative terminal of a battery. So this is the direction of current flow, and this is the direction of electric field, and this is the direction of electrons motion. Okay, so and these electrons will be moving with a velocity. Okay, so that can be represented by Vd. Okay, that is the drift velocity of an electron. So this is what you are going to write as a description. Okay, whatever you have understood in the diagram, that you are going to write as a description. Okay, let us see in a simpler way how we are going to represent this, that what we have understood here. The length L is the length of the cylindrical metal wire. A is the area of cross section of the wire. P is the potential difference applied across the wire, and E is the electric field set up in the wire. Vd is the drift velocity of electrons. I is the current in the wire. So these are the points we need to include in the description. Okay. So now let us see the very important formula, that is V is equals to IR. So this is from Ohm's law. So we have V is equals to IR, and if you rearrange for I, so what I get, I'll just take this R to the denominator. So I get I is equals to V by R. That forms an equation 1. So if you get this equation, that is completely enough. So we can substitute the values that we know. That is, we are going to substitute for R. What is the R formula that we have here? That is, R is equals to rho L by A. That we are going to substitute in the place of R. So we get so rho L by A we get. Okay. So then we know we can take this A to the numerator, so that becomes a VA by rho into L. Now what is I? That means when I take this A to the denominator, so that will become I by A. So what is I by A is, that is J. So you can substitute, we are taking A to the denominator here, right? So I have I by A is equals to V by rho into L. So I by A is nothing but J, and 1 by rho is what? Here 1 by rho is sigma, so I have substituted sigma here. So V by L is nothing but, that is electric field intensity. So I get J is equals to sigma E. Thank you.